The Gear Up Robotics Summer Academy was a 4-week program working with students in 7th and 8th grade from various high schools across Chicago. It was an opportunity to challenge them with a fun and interesting curriculum that investigated real-world issues in math, science, and technology while they explored a college campus. The academies were held at Northeastern Illinois University and Roosevelt University in Chicago in June and July of 2012. The academies stressed problem-solving in groups to simulate the professional experience in engineering within a community of practice. Participating teachers were hired from schools all over Chicago and underwent intensive professional development in robotics, design, and inquiry-based learning. Students and teachers were supported throughout the project by Gear Up staff, as well as parent mentors and college student mentors. Students either worked on CarBots or VEX Robotics. The CarBots were made from Texas Instrument or TI calculators set atop a set of chassis and wheels. The VEX Robotics design system was developed for engineering education and is an element in international competitions. In the CarBot groups, problem solving was a twofold project. Students had to learn basic programming to make the CarBots move in the way that they wanted them to. They were assigned various missions to ensure they had understood how to make their CarBots move forward, backward, turn, and navigate complicated pathways. Students also had to design acrylic car covers that addressed the design purpose they had for their CarBot. They learned the design cycle, undergoing every step from brainstorming to prototyping to final design. Using the latest in manufacturing technology, the designs the students created were cut out of acrylic at the Museum of Science and Industry and Pumping Station 1. Both the museum and Pumping Station 1 have Fab Labs. Fab Lab is short for Fabrication Laboratory, small-scale studios for digital fabrication that include laser cutters and 3D printers. In the VEX groups, students also had to learn programming while they developed the structural understanding of robots, learning how to use elements like sensors and microcontrollers. The students worked on complex challenges, including a speed test, a tug-of-war, and ramp climbing. The programs included guest speakers who are industry professionals in science or engineering, allowing students the opportunity to interact with people that work in science, technology, engineering, and math, or STEM fields. Students also took a field trip to the Museum of Science and Industry, where they were able to experience the Fab Lab and see other examples of scientific innovation. In addition to working with robots, students had lessons in literacy and math in order to support the work they were doing in engineering. In the literacy classes, they explored the inquiry cycle and kept engineering notebooks to better understand the role of observation and reflection. In math, students reinforced concepts necessary for programming and building their robots, like gear ratios, circumference, and percentages. In the final assessments, which included surveys, tests, and written personal statements, students demonstrated positive attitudinal changes towards careers in STEM, and they made gains in their math scores. However, the results of the program were best on display at the Student Symposium, held on the last day of the program. Students presented their work to family and friends and displayed documentation of their process, including their prototypes. They also demonstrated how they had bonded as a group, making new friends from different parts of the city as they moved on to the next year in middle school. For more information on the Robotics Summer Academy, you can visit the following websites. Here, you will be able to find the students' personal statements, as well as pictures and videos of the great work they did.